Okay, we're going to talk about brainstem features and answer the what questions. What are the three parts of the brainstem, and what are the primary internal and external features of the midbrain, pons, and medulla, and their functions? Hello, everyone. My name is Dr. Morton, and I'm the noted anatomist. Okay, so the brainstem consists of three parts. It consists of the midbrain, the pons, and the medulla, sometimes known the medulla oblongata. So here's a brainstem in anterior view, and so this top part here, there's the midbrain, and just below that is the pons, and then below that is the medulla. And so there they are in yellow, purple, and green. And so now let's take a line and separate right down the middle, divide them, and take one half and rotate it. So now we're taking a look at a sagittal section of the brainstem. And we can see again the most superior or rostral part is the midbrain in yellow, pons in purple, and the medulla in green. And then below that, we can see the spinal cord continuing down through the vertebral canal, though you can't see the vertebral canal. So this tutorial is an overview of primary internal and external brainstem features, but it's not an exhaustive resource on brainstem anatomy. This is meant to be a kind of an overview of internal and external features, the major ones and their functions. So let's talk about midbrain first. And so the midbrain is the most rostral part of the brainstem, and it's rostral to the pons. So there in yellow is the midbrain, and there's the pons. It's superior or rostral to it. And so midbrain means middle of the brain, mid. It's also known as the mesencephalon, that embryonic term, because meson means middle and cephalon means brain, so the same things. And so there we have an embryology illustration of a developing neural tube, and in yellow is the mesencephalon, and then we see the developing tube in an adult. That mesencephalon is in the middle of the brain, hence the name. So here are all the different internal and external structures in the midbrain that we are going to cover in these succeeding slides. So the first is called the tectum. And there we have the tectum. It's the most posterior region of the midbrain. And you can see in this illustration at the bottom it says brainstem posterior view. And in yellow is the tectum. It's dorsal to the cerebral aqueduct. Okay, so there's the tectum. And so if we then take a line and divide it, separate it, take one half and then twist it, so we look at a mid-sagittal view, it's the tectum is this posterior region. There is in yellow outlining where the midbrain is, and this highlighted part is the tectum. It's the most posterior part of the midbrain. And then it's dorsal to the cerebral aqueduct. So if we look inside that area, there we see that blue line. That's showing the cerebral aqueduct, and the tectum is dorsal or posterior to that. The tectum is Latin, which means roof. And so it looks like there's the roof of the midbrain, just like if we look at a car, there's its roof. Now, the tectum also has a component called the quadrigeminal plate, and quad means four, and there's these four swellings on the dorsal part of this midbrain in the tectum, 1, 2, 3, and 4. And so if we take a look at this mid-sagittal view and blow it up, we can see a bump. So anatomists were like, there's a bump. What do we call this bump? Hey, you know what? It looks like a hill. Yeah, like the one that Jack and Jill went up. That's a good idea. Why don't we call it that? We'll call it the hill, except they're using Latin, which is colliculus. And so when we now take a look at the quadrigeminal plate, they call that the colliculus. But it's on top, so we call it the superior colliculus. And then the one on the bottom, they call it the inferior colliculus. And so that's singular. But if we do plural, we use superior colliculi. And the bottom, those are the rostral or superior bumps. And then the inferior colliculi are the caudal or the inferior bumps. So if we then take a cross section through the rostral part of the midbrain, through the superior colliculi, this is what it looks like, where there's the superior colliculi, and the superior colliculi function in that they, for preliminary visual processing and the conjugate vertical gaze center. And then if we take a look at a cross section through the inferior colliculi, those bottom two bumps are the inferior colliculi and therefore auditory processing. And so here we have a recap. We call that whole area there the tectum. And then we call those four swellings on the tectum the quadrigeminal plate. And then we call the two superior bumps the superior colliculi, and the inferior bumps or hills the inferior colliculi. All right, now continuing. In this mid-sagittal view of the brainstem, in purple, we see the choroid plexus. They're actually located in each of the ventricles. And so in this case, we can see it in the third and fourth ventricle, and the choroid plexus produces cerebral spinal fluid, or CSF. And so there we have the choroid plexus in the third and the choroid plexus in the fourth ventricles. And then we see those arrows are showing, they're producing CSF going in the third and in the fourth ventricles. And so the cerebral aqueduct courses vertically within the midbrain, as shown in that blue vertical line. And so the cerebral aqueduct courses vertically and connects the third and the fourth ventricles. So there's the third ventricle and there's the fourth ventricle, and we see it connecting the two, and there's CSF flowing throughout. And so in this mid-sagittal view, we can see also in this more ghosted lateral view of the brain, and there is the cerebral aqueduct coursing up and down, connecting third and fourth ventricles. So if there's a blockage in the cerebral aqueduct, as is evidenced by that yellow thing, whatever that is, as CSF is trying to go from the third to the fourth ventricle, it's blocked, and this results in a non-communicating hydrocephalus. Non-communicating because CSF can't get from inside the ventricular system to the through those apertures in the fourth ventricle to the subarachnoid space. Okay, so there's the cerebral aqueduct. So hey, how about another name for the same structure? So there we have the embryonic term, and anatomists were like, hey, in the embryonic part of this developing brain, there's an aqueduct. What should we call it? Hey, it's in the mesencephalon. Let's call it the mesencephalic aqueduct. That's a good idea. How about another name? Well, why don't we call it the aqueductus Sylvius, named after the he's German, but the Dutch anatomist Franciscus Sylvius. We'll call it the Aqueductus Sylvius, or the Sylvian Aqueduct. And you know what? He looks a lot like Sir Ben Kingsley, especially if you do that. Okay, so the cerebral aqueduct in cross-section now through the midbrain is going to look like this. And there we have that cerebral aqueduct, just like a straw in cross-section. And surrounding the cerebral aqueduct is the structure called the periaqueductal gray, which is the control center for descending pain modulation. And so for now, I'm not going to go into any more detail other than that's a landmark to look for, that gray matter surrounding the cerebral aqueduct. Then there's this other term that we see quite often called the tegmentum. So the tegmentum is the region between the cerebral aqueduct and the cerebral peduncles. And so there we have it. So there's our cerebral aqueduct, and there's those cerebral peduncles, and it's that yellow shaded area, all that area in between there. Now within that tegmentum is some structures, one being the red nucleus. So there's our red nucleus, and it gets its name because the pink color, red color, is due to the iron in the hemoglobin and the ferrin. And it's a great landmark because if you see the red nucleus, then you know you're at the level of the superior colliculi. Because if we then go shing and go down to the level of the inferior colliculi, you notice there's no red nucleus. All right, so the red nucleus, its rostral location indicates the level of the superior colliculi, and it helps in the motor coordination as part of the extrapyramidal system. Now next is some area called the reticular formation, and it forms the central core of the brainstem, as evidenced by that kind of orange area there. And the nuclei are not that obvious. It kind of makes a formation. It looks like reticular just fibers going side to side, and the nuclei aren't quite as obvious. And so the intermingling of axons gives the formation its name. And its function is it mediates a level of consciousness. All right, so next is the substantia nigra, that we can see that dark shaded area in this section of the brainstem, and its dark appearance is due to the neuromelanin and dopaminergic neurons. And so it courses from here to here, and it's a very good landmark on identifying midbrain. You can see the substantia nigra in cross sections, coronal sections, or even sagittal sections. Now, if we go down to the level of the inferior colliculus, we can also see the substantia nigra. So it's consistent all through the rostral caudal levels of the midbrain. And the substantia nigra functions in reward, and as a result, it also plays a part in addiction, and it's also plays a part in movement in the extrapyramidal system and also in the basal ganglia. This also plays a role and it degenerates in Parkinson's disease. So this next is a structure called the cerebral peduncle. It's got this anterior lateral location, and there's the cerebral peduncle, and it courses from up to down or vertically. And if we look at this lateral view, we can see this whole area in pink is the cerebral peduncle, or this posterior view, that whole area is the cerebral peduncle, and it has axonal fibers that course vertically. Now, what does peduncle mean? Well, it's Latin for foot. In botany, they use the word peduncle for a short stalk at the base of like a leaf. And in anatomy, the word peduncle is a stem connecting a massive tissue to another massive tissue. And in neuroanatomy, a peduncle is a bundle of neurons connecting different parts of the brain. So all this together means the cerebral peduncle is a stalk of nervous tissue that connects the cerebral cortex with the spinal cord, brainstem, and pons. And so the names for the following person have become more or less interchangeable. I'm on a bit of a tangent here. So you take a look at this person and you go, oh, yeah, that person, that's Calvin Broadus Jr., also known as Snoop Dogg, or just the abbreviated Snoop, or previously known as Snoop Doggy Dogg, and more recently Snoop Lion. Now the names for the following structure have become more or less interchangeable. We call this the cerebral peduncle. But also now it's become known as the crus cerebri, or also the basis pedunculi. And so thank you, Anatomist, for making the cerebral peduncle like Snoop Dogg. All those names mean the same thing. Okay, so the cerebral peduncle, if we now take a cross-section through it, looks like this. And so that whole area in pink is the cerebral peduncle. And because we've got these descending fibers, axonal fibers that go from the cerebrum to the spinal cord and the pons and other parts of the brainstem, I'm just going to focus on one. It's called the corticospinal tract right there. Okay, and so this relays long motor tracts from the cerebrum to the spinal cord, but to the contralateral side of the spinal cord. Now, how does that work? Well, let's just show you the schematic we're going to be using. Here's a cross section through the L4 level of the spinal cord. With one side, we can see the roots and rami. And then there's one level at the T4 and another through T7. And then there is the medulla and the C1 level of the spinal cord showing the decussation. And then there's a cross-section of the pons, a cross-section of the midbrain, and then there is a coronal section of the cerebral cortex. So all of these are cross-sections from brainstem through spinal cord, but then in the cerebral cortex is a coronal section. All right, and there's the right side and there's the left side. Those are all going to be important as we use this illustration throughout this tutorial. And so cerebral peduncle has the corticospinal tract that relays long motor tracts to the contralateral side of the body. So let's take a look at that picture and go shing and place it inside this schematic. And then we take a look at a cell body for an upper motor neuron in the right side of the cerebral cortex. And that axon descends, and right there in that kind of rose color, we see this axonal fiber. And then let's follow it. And it descends down, it decussates at the pyramids, and then descends all the way down to the contralateral side of the body, where it synapses with a lower motor neuron that goes and innervates a lower limb muscle. But if we blow this thing up, that's all we see. So we now have to superimpose these descending fibers going down at this level and then knowing they're going to go to the opposite side of the spinal cord. All right, so the next structure we're going to talk about is the spinal thalamic tract, or the ALS, which stands for anterior lateral system. And there it is in green. And so the spinal thalamic tract relays pain and temperature from the contralateral side of the body and going to the thalamus. And so there we have the substantia nigra. And if you can find the substantia nigra in the dorsal part of it, we're going to find that spinal thalamic tract just medial to it, staying along that posterior margin of the midbrain. So if we take this section of the midbrain, put it in the schematic and go shing and place it in there, and now we're going to take some skin that's in the lower limb on the left side, and so then take a pin and prick the skin. And we see a first order neuron comes in and then synapses with a second order neuron that decussates to the contralateral side, and watch. In the anterior lateral system, or part of the spinal cord, this fiber ascends all the way up through the different segments of the spinal cord, and then bottom part of the brainstem, and then shing, right there in green, is where this ascending information is relaying pain and temperature from the contralateral side of the body up to the thalamus, and then eventually to the cerebral cortex. But all we see is that when we take a look at this cross section of the midbrain. All right, so next is something called the dorsal column medial lemniscus, or DCML abbreviation, tract. And it's there in blue. And so the way this function relays vibration and proprioception from the contralateral side of the body up to the thalamus. And so how do we find it? Well, there's the substantia nigra, and then there's the red nucleus, and it's right between the two, kind of sandwiched between the two is where we find the DCML tract. It's relaying vibration and proprioception from the contralateral side of the body to the thalamus. Well, let's do this again. Take this little section and go shing and place it inside this schematic. And let's take a tuning fork and hit it on the skin of the lower limb, and this on the left side. And so the skin vibrates in this L4 dermatome, and a first order neuron brings this information. It stays ipsilateral as it sends all the way up to that spinal medullary junction. It synapses with a second order neuron, which then decussates to the contralateral side and ascends all the way up, and right there we see in blue this ascending information that's relaying vibration and proprioception from the contralateral side of the body up to the thalamus and eventually to the cerebral cortex. But when we take a look at these sections, all we see is that. All right, so the cranial nerves coming off the midbrain are oculomotor and trochlear, cranial nerves 3 and 4. And so there's our oculomotor nerve. It exits ventrally from the midbrain and courses out and innervates 4 of the 6 extraocular muscles, as well as the ciliary muscles and the pupillary constrictor muscle. Now, when the oculomotor nerve exits, it courses between 2 arteries, the superior cerebellar and posterior cerebral arteries. If we zoom in on this, there we have in yellow is cranial nerve 3, and there's the posterior cerebral, and there's the superior cerebellar artery, and it exits between the two. And this is important, so if there's ever a baryaneurysm, that baryaneurysm may compress and then affect negatively that cranial nerve 3. Now, cranial nerve 4, known as the trochlear nerve, is shown there. Now, this exits dorsally from the midbrain. It exits dorsally and wraps around the cerebral peduncle. You'll see it's exiting just below that inferior colliculus, wraps around the cerebral peduncle, and then courses ventrally out and goes and innervates the superior oblique muscle. Now, the functional significance of the midbrain. Well, this helps with coordination with eye movements. It is one of the relay neurological levels that affects the pupillary light reflex, and it also helps with consciousness and arousal through that reticular formation. Now, how do you identify the midbrain and cross section? Well, some of them you just look for things, the landmarks that you've got to know, like, oh, there is the cerebral aqueduct. Okay, I can see that. Oh, hey, there's the red nucleus. I can recognize that. Or you could also say, oh, there's the substantia nigra. It's darker color. Or there's the cerebral peduncle. I see that. Or you take a look at these two things and say, hey, it kind of looks like someone doing the splits. There's one way. Or you might say, hey, you take a look at that. It kind of looks like the ears from Mickey Mouse. Okay, so either way, you can identify what the midbrain looks like in cross section. All right, now on to the pons. Okay, so the pons is the bulging portion of the brainstem, and it's shown there in yellow, and its topography is that it's there, and it's basically rostral to the midbrain, and it's, it's caudal to the midbrain, it's rostral to the medulla, and it's anterior or ventral to the cerebellum. Now, the topography, as I just mentioned there, I don't know my own slides. Okay, so in the pons, these are the structures the internal and external structures we're going to cover for the pons anatomy. Here's a mid-sagittal view of the brainstem showing the pons, and the pons proper is this anterior bulge, this front bulge we see in the pons. And if we take this in cross-section and look at it, it's here. There in yellow is this anterior bulge, and we can see these cerebellar tracts that go side to side where we have this bridging action between information going through the middle cerebral peduncle, probably middle cerebellar peduncle going to the cerebellum. In the middle of this pons proper in pink is a structure called the corticospinal tract. There it is there. And so you're saying that term sounds familiar. We're going to hit this structure at all levels of the brainstem. And the corticospinal tract, as we talked about before, relays long tracts to the contralateral side of the body. All right, so if we now take a look at this picture here and put the pons in, we see an upper motor neuron that descends and then stop. Right there, we see this descending or this long motor tract en route to the contralateral side of the body. Well, let's continue it then. All the way down, it decussates there at the pyramids and then descends all the way down. We're on that contralateral side of the body, synapses with the lower motor neuron, in this case at L4, which innervates some lower limb muscle, like your quads. Okay, but if we then blow this up and look at the pons proper in this way and see that cortical spinal tract, you now have to superimpose your knowledge on that picture. There's another structure called the middle cerebellar peduncle, which is the largest of the three cerebellar peduncle, and it contains fibers that arise from the contralateral pontine nuclei, and it courses to the cerebellum. There'll be more on that in other tutorials. There in blue is the fourth ventricle. It contains cerebral spinal fluid, and this fourth ventricle communicates with the third ventricle via the cerebral aqueduct, and it continues down into the medulla. So there we can see that cerebral aqueduct going up into that midbrain. And there's the third ventricle, continuation from the cerebral aqueduct and down below, through the medulla and that fourth ventricle, that whole continuation of this ventricular system. Within the pons, there's also the reticular formation, and it's located in the pons proper and just in front, between that, and it's located between the pons proper and that fourth ventricle. All right, now the spinal thalamic or ALS tract. There it in green. It's a smaller structure. Now its function is to relay pain and temperature from the contralateral side of the body to the thalamus. Same one that we talked about in the midbrain. And we find it by I find the bulge of the pons proper, and then I just kind of go down to the side, like as if I'm going down the slide of a hill, and then I find that middle cerebellar peduncle, and it's in between that, laterally within the pons. And so if we take this section of the pons and then superimpose it in the schematic, and then we take a pin and prick the L4 dermatome on the left side, watch a first order neuron comes in, synapses with a second order neuron that decussates to the contralateral ALS, anterior lateral system, and then that axon ascends all the way up, and then right there in the pons is this information relaying pain and temperature from the contralateral side of the body, and it continues up to the thalamus and then ultimately to the cerebral cortex. But again, all we see is that when we look at a cross section. Now the dorsal column medial lemniscus or DCML tract, just like we talked about in the midbrain, this is going to relay vibration and proprioception from the contralateral side of the body to the thalamus. How do I find it? Well, I see the front of the pons proper. Just go into the pons proper and find the cortical spinal tract, and then you just go a little bit more. It's between the front and it's basically right in the middle near the midline in the pons. And so if we superimpose this picture, and now let's take a tuning fork and hit the L4 dermatome on the left side, and a primary order neuron takes that information, which ascends ipsilaterally, and then synapses with a second order neuron at that spinomedullary junction, and that axon decussates to the contralateral side and ascends up to the pons there. So right there in the pons is vibration and proprioception ascending, but the information is coming from the contralateral side of the body up to the thalamus and ultimately the cerebral cortex. But again, when you see a cross section, all we see is that. Okay, so the pons has the following cranial nerves. Cranial nerves V3, basically 5, 6, 7, and 8, but we're talking about motor, and so we're going to just talk about V3 for the mandibular nerve at this point. And so here we zoom in. There's the V3 or trigeminal nerve, and even though it just says mandibular nerve, there's all three branches of the trigeminal nerve, but I wanted to focus right there because that's showing the branchial motor component that is going to be going to innervate muscles of mastication. Then there's the abducens that exits ventrally right between the pons and the medulla that goes and innervates the lateral rectus. And then there's our facial nerve that exits more laterally at that junction between the pons and medulla. And that innervates muscles of facial expression and then does visceral motor to two of your salivary glands and nasal palatal glands and your lacrimal gland, and also helps with taste from the front of the tongue. And then we also have the vestibulocochlear nerve, cranial nerve 8, that looks kind of like a celery stalk. That's going to be providing sensory innervation of your hearing and balance. Okay, so there are the 4 principal cranial nerves associated with the pons. Now, the functional significance of the pons is that it's a reflex control of the respiratory system, and it's important in eye movements and the coordinated movements of the eyes and head, and it's the neurological level associated with the corneal reflex. You touch the cornea with a wisp of cotton, patient will blink both eyes. So how can you identify the pons in cross-section? Well, you identify these structures like, hey, there's the fourth ventricle. I can see that. It's really big. It's at the back. Or, oh, there's that middle cerebellar peduncle. I can see that big thing coming off the side. Or, oh, there's the cortical spinal tract that's right in the middle of the pons proper. And also, when you just take a look at that pons proper, it kind of looks like your Uncle Bob's belly. And if you see a cross-section that looks like a big belly, you know you're in the pons. Now, let's talk about the medulla, also known as the medulla oblongata. This is the most caudal portion of the brainstem, right there. It's below the pons, and it's between the pons and the spinal cord. And so here are the structures, the internal and external structures that we are now going to talk about with regards to the medulla. Here's an anterior view of the brainstem and the medulla, and then in pink, there's the pyramid. And it's these paired ventral midline bulges that course the length of the medulla. And if we take a look at it in cross-section, it's those pink structures right there. That's the internal, what the pyramids look like internally. Now let's take, this contains the cortical spinal tract. You're like, that sounds familiar because we've already talked about it twice in the midbrain and pons. So let's take this section, put it right inside there. And then we take a look at this upper motor neuron that descends down, and right there is where we see this descending fiber right there in the medulla, which decussates through the pyramids to the contralateral side, and then descends in the cortical spinal tract in the spinal cord white matter, and then it synapses with the lower motor neuron, which innervates some lower limb muscle like a quad muscle. So let's take this section and blow it up a little bit. And let's talk about some medulla jargon for a minute. Sometimes this is one of the hardest things is you just have a lot of words and it's hard to associate them with the clinical aspects and just the structures in general. So that is showing a cross-section of the medulla. That is showing a cross-section of the C1 spinal cord. And the space in between is called the spino-medullary junction. Spino for spinal cord, medullary for the medulla oblongata, the spino-medullary junction. And then we talk about these upper motor neurons. And they're called upper motor neurons because they start way up in the cerebral cortex, and then they descend. And what happens is this upper motor neuron courses in the pyramids of the medulla, but then somewhere near the bottom of the medulla into the spinomedullary junction, this decussation occurs. Decussation means a crossing over. So this cortical spinal tract are these upper motor neurons that course down the pyramid, decussate in the spinomedullary junction, and then descend in continuing this tract of upper motor neurons that go from the cerebral cortex to the contralateral spinal cord called the corticospinal tract. I'm hoping that might be helpful in taking all these terms and trying to understand them. All right, some other structures in the medulla is called the olive. They're in yellow, these paired anterior lateral bulges that are just lateral to the pyramids. And let's take a cross section and see what this looks like. These paired anterior lateral bulges contain the inferior olivary nucleus, very characteristic of the medulla. If you've ever seen that squiggly dentate looking nucleus, you know, aha, there we've got, I sound like a pirate there. I don't know where that came from. There we got a cross section through the medulla. More on that, on its functions, but right now it's basically so you can identify one of the features that identifies the medulla. At the back of the medulla is this fourth ventricle, which contains cerebral spinal fluid, and the fourth ventricle is where the CSF communicates with the subarachnoid space via the medial and lateral apertures of Magendai and Luschka. Okay. Now, in orange there is the reticular formation, which you'll notice we talked about in midbrain and pons, and now medulla, which plays a key role in cardiovascular and respiratory systems. All right, in green is the spinothalamic tract, or the ALS tract. And this is relaying pain and temperature from the contralateral side of the body to the thalamus. You're like, hey, this sounds familiar. This is like a broken record. But it's always repetition I'm hoping is helpful. So how do we find that in this cross-section of the spinal cord? I use friendly faces. I take a look and say, pyramids, I can identify that. Oh, and just lateral to that is the inferior olivary nucleus. So I know it's that. So if I just keep laterally on the periphery, right behind that is where you're going to find the spinal thalamic tract. Okay, and so if we now take that section and place it in the schematic, and then we take a pin and prick skin in the left side of the L4 dermatome, we're going to see that information comes around and ascends, and then right there again is pain and temperature coming from the contralateral side of the body, ascending, going to the thalamus, and then watch, it goes through that part of the pons and midbrain, thalamus up to the cerebral cortex. Okay, so there we have the spinal thalamic tract in the medulla. Now, the dorsal column medial lemniscus tract is a relaying vibration and proprioception from the contralateral side of the body to the thalamus. And so there, how I find it is I find the pyramid, and then this DCML tract is just immediately dorsal to the pyramids, and it spreads a good chunk in through the mid portion of the medulla. And so if we now place that within our schematic, there we have a tuning fork that hits the skin in the L4, left side of the L4 dermatome. That information ascends ipsilaterally, synapses with a second order neuron that decussates to the contralateral side and ascends up there. So there in that part of the medulla is vibration and proprioception ascending to the thalamus, but it's taking information from the contralateral side of the body up to the thalamus and ultimately cerebral cortex. And there we have the DCML tract in the medulla. In fact, right here, it's really just called the medial lemniscus because it looks kind of like a ribbon the way it ascends up through the brainstem, and the dorsal column is for the spinal cord. But for the whole tract, we just call it the DCML tract. All right, now the cranial nerves associated with medulla are cranial nerves 9, 10, 11, and 12. And so there's the glossal pharyngeal nerve, cranial nerve 9, that innervates stylopharyngeus muscle, clinically not so significant. Does the taste of the posterior third of the tongue and oral pharynx? Kind of. General sensory to the posterior third of the tongue and oral pharynx. That's important for the gag reflex. And then it also innervates the parotid gland. Then there's our vagus nerve, that is cranial nerve number 10, and that's the vagabond. That's the one that goes and provides parasympathetic innervation to the heart, lungs, and foregut, midgut, and associated organs, but it also does branchial motor to your palatal, pharyngeal, and laryngeal muscles, which is very important, especially for swallowing and speaking. And then there's our spinal accessory nerve that kind of arises from the more rostral part of the cervical spinal cord, that ascends up through the foramen magnum and then descends through the jugular foramen with cranial nerves 9, 10 en route to innervate the traps and sternocleidomastoid. And then there's our hypoglossal nerve, cranial nerve number 12, that innervates all the tongues of the muscles of the tongue, helps you move your tongue out of your mouth, and it exits the medulla between the olive and pyramid. It's very easy to find on a brain. All right, so there are our 4 cranial nerves associated with medulla. Now, what is the functional significance of the medulla oblongata? Well, it has a reflex control of cardiovascular and respiratory systems, and also reflex control of swallowing and vomiting, and it's important in phonation, control of the tongue, and movement of the laryngeal muscles and pharyngeal muscles. Now, how do you identify the medulla in cross-section? Well, you can say, hey, look, there's the fourth ventricle. I can recognize that. Or, oh, there's the pyramid. I can recognize that near the midline. Oh, there's that cool inferior olivary nucleus. I can definitely tell that. Or you take a look and you say, you know what that looks like? That looks like a plumber's crack. If you ever take a look at a cross-section of the brainstem and it looks like a plumber's crack, you're in the medulla. And so let's now, in review, talk about the brainstem in a nutshell. So here we have an interview of the brainstem, and it's comprised of the midbrain, pons, and medulla. And in cross-section, the midbrain looks like this, and there's all the structures associated internally and externally. And the pons, there's a cross-section, and there's all the structures that are internal and external in the pons. And there's a cross-section of medulla, and all the structures that you need to know for internal and external. And there, my friends, is the brainstem in a nutshell.